Welcome back, class. Glad to be back together. Last week, the video covered, cordless drill, impact drill. Uh, also talked about bits and tips and screws and uses and best types, that type of thing. Today, we're going to cover the significance of the term square. Something that's very important, probably overlooked a lot, is the significance of square. And we'll cover methods of square. There's a lot of different ways you can do it. Methods for small projects, methods for larger projects. So, if you learn the different methods, you'll learn when and where to use them. All right, we want to check this thing for square. So we're going to measure from corner to corner. This corner says I got 100 and almost a half inches. Let's check this side. See, this long tape, this wide tape works good. Right here, I got 98, right at 99 inches. So what's that telling me? This is 99. This was what? 100 and a half. From this corner to that corner is an inch and a half bigger. So if this size here is bigger than this size, I want to make this from here to here longer. How can I do that? All you got to do is take this corner and push it that way. See how it slid? It slid down. So if you had a 1.5 inch difference, if I slide it down 3/4, that's going to make this one 3/4 longer, this one 3/4 shorter, because I slid it that way 3/4. So now it should be fairly close. Check it again. I got 99 and 5/8. Check it this way. Looks like I got 99 and 5/8. But we right on it. So that's how you square up something. One of the fundamental aspects of carpentry refers to the term square. Square refers to having 90-degree angles. It's also called right angle. In some cases, there may be a project or part of a project that calls for specific angles that are not 90 degrees. But for the construction of all other projects, having a perfect 90-degree angle is a must. So why is it so important that what we're building is square? For instance, in this frame, these corners are square, 90-degree angles. These corners are not square. It's obvious that if you're building something and it isn't square, you're going to have some problems. One of the main reasons is most building materials are made to be installed at 90-degree angles. Say this frame is a 4-foot by 8-foot frame. If you lay a sheet of plywood on it, well, you got a situation. But sometimes it can be adjusted. You could adjust, slide it over to make it square. But sometimes you can't. If it's something that was done previously that can't be adjusted, you got some problems ahead. The framing square here shows that this corner is not square. This is most likely the result of a failure to make sure the foundation was square at the very beginning of the construction process. I want us to look at some examples of how not having right angles can cause problems. Let's say this example here is representing the installation of some floor tile. Here the building is square, but the layout of the lines that have been snapped are not. You start by laying the first tile where the lines intersect. Then you continue with the next one, then the next one. All right, now the first row is done, and when all the hole tiles have been laid, you have these terrible looking jogs in the tile here, and the borders will be off also. So let's look at another example. All right, in this situation, the layout of the lines has been snapped correctly. They intersect at a perfect 90 degrees. First tile is always laid at the intersection. Then another. You can go any direction you want to as long as you lay to the line. All right, your first row is done. So we go back to the line and start the next row. Finish your second row. Finish your third row. When you get done with all your hole tiles, you realize there's an awful cut up against the wall. Here, all these tiles will have to be cut at an angle, and each one will get wider and wider as it goes across the room. So that won't look very good. The floor's out of square, so the ceiling will be out of square. The roof will be out of square. This is just a good example of when you start a project, make sure you take the time to get it right. Because if you don't, it's going to be a problem from now on. And for the last example here, you have a floor system that's not square. And while laying the plywood for the subflooring, you'll experience some pretty bad problems. So you get the first line of decking installed. All right, here, all the subfloors are in place. And when the decking is laid, the joists are covered so you can't see them. But each sheet will be nailed at the ends here. You know, like this is a sheet of plywood. It'll be nailed at the ends. And the subflooring usually has lines that are marked to show you where to nail each joist. Like these perforated lines here. I put those to represent, you know, a nailing mark on the sheet of plywood. Now, on the plywood, it will have more because they would be laid out on 16-inch centers, but I thought less lines would be clearer to see the example here. All right, so this is kind of be a pattern of, you know, just an example of how it would be nailed. You know, you put nails on the ends here, like these ends, put them here, and on the lines that are pre-marked on the plywood, you always nail them right on those lines. But now you can see the problem. Because the frame wasn't square, only a few nails hit the joist. Like these hit, but very quickly, none of these nails even hit the joist. This is exaggerated a little bit. You know, I drew it way out of square so you can see. But I've run into problems similar to this, not this extreme, but you would have to go back and cut a piece of wood and nail it to the joist here to have you something to nail to up on there. You know, when something's out of square, it's going to cause problems. The building can still be built, but things not going to look as good, and you're going to have some structural problems that's just going to cause you a lot more work. So let's look at some real examples of why square is so important. I mean, this foundation, if it's not carefully constructed at 90-degree angles, there'll be some serious problems from this point on. Here's another example. This guy's laying the subfloor. We got 90-degree angles. Here's the interior wall, hanging drywall. If this isn't a 90-degree angle in the corner, well, that piece is going to have to be cut. It's just more work. Instead of just being able to pick it up, nail it in place, you got to cut it to make it fit the wall. And then you got to be more careful about where the studs are. Here on the roof, 90-degree angles. We talked earlier about laying floor tile, how important it is. Roofing, 3-tab shingles, metal roofing, everything's got to be squared up before you get started. You also have some problems with furniture or cabinets, things not square. Inside, like interior walls here, 90-degree angle. The cabinet fits perfectly in the corner. But if it's out of square, you're going to have a big crack here. Or if it's out of square this way, it won't fit back into the corner. So no matter what we're building, we realize the importance of getting things square. Now let's look at some different ways we can be sure things are square.
Hey, I'm building a shed in my backyard. I'm at the point right now where I'm building the floor. I have the outside walls, what kind of looks like a sandbox, but it's going to support the floor joists across. Now before I go any further, I need to make sure that this is an exact rectangle, because if you have it off a bit and it's a parallelogram, then it leads to all kinds of problems as you build the building. Now we've talked about how to check if something is a rectangle before. Those need to be right angles. They all need to be exactly 90. Now one way of course you could check it is using a Pythagorean theorem. You could measure that side, you could measure that side, and then you know how long the diagonal is, doing some calculations. But since it's a rectangle, there's actually an easier way to do. We want it to be a rectangle. Now a property of a rectangle is that the diagonals, the two diagonals, that distance to there and that distance to there, should be equal. If it's an exact rectangle, those should be equal. So I'm going to measure them and we'll see. If they're not equal, then we know we have some stuff to fix. So we'll measure this one first. And see what we have here. We have about 189 1/4. And we'll measure the other one. Right here. Let's see what we have. We have about just over 191. So those are a couple inches off from each other. So what that means is this one's longer than that one. So it means even though it looks like a rectangle, it's slightly like that, it's a parallelogram. So we have to fix that by squaring this off. So I'm gonna knock these boards this way and see how we do here. See if that's good. All right, let's check that now. See what we're looking at. We'll measure this one again. I moved it about an inch there, is my guess. That is 190 1/4, roughly. And this one is, we'll see. Look at that, 190 1/4. So, now that those two diagonals are exactly equal, we know that this is an exact rectangle, a right angle. So there you go, using a property of rectangles to figure out that your building's going to be good when you make it.
A framing square is a good tool to square up, to make sure we have a 90-degree angle on small things. This piece of wood I cut is 12 inches by 16 inches. We can look to ensure that it's square by making sure it's a 90-degree angle. We can look at this little frame that I built. It's also 12 inches by 16 inches. So this should fit perfectly on top of it. So I take this piece of wood, I get it flush here along the bottom, and I check up here. This is not fitting right. So this is square. The frame I built evidently is not. So we have to make some type of adjustments. Something's gonna have to be done to get this square. Say if this was a house, the foundation was built out of square, and you begin to lay your plywood on top of it. This is a small area. This is 12 inches wide. How far off is that? Only about that far. This is 1 foot wide. What if your house is 30 foot wide? Multiply this amount by 30. It could be way off. So nothing is going to fit right. So you got to make sure everything's 90 degrees, because as the project gets bigger, so does the problem. So if you're putting plywood on top of a frame you built, the easiest way to do it, square it up. If you know the top square, just get this line here perfectly flush. Go ahead and nail it, screw it, whatever you're going to do. Once you get it screwed, well, if this is attached, it can't move, then I can just push this over till it gets there, put a nail in it there, and it's square. Alright. Now, the framing square is a great tool for a lot of different things, but in squaring something up, making sure it's 90 degrees, something small, this is perfect. Let's say if you were trying to square up a building that was 80 feet long, and I pull a string line, you know, I start here and I say, okay, this is the corner of my building, and I just want to get this string perfectly in line with this square and run it out there 80 feet. Line it up here, and then I should be square. Well, if I happen to be, say it was a 16th to make it easy, and the building was 80 feet. If it was a 16th off here, out there, it'll be 80 16ths off. If it was a 16th off, right here, and we were using our frame square to square up a building 80 feet long, 1/16 here would be 5 inches. That's how far out of square that building would be. They would make you tear it down and start over. That would be just terrible.
There are several reasons why you might want to identify a right angle. Perhaps you're building a raised bed, building a fence, or building a deck. It's a pretty simple method that we're going to use here called the 3-4-5 method. And in order to do that, we're going to need some string, a tape measure, and 3 pins. So we're going to first put our first pin right here at the corner where we want our 90-degree angle. At that point, we're going to measure a distance of 3 feet from that pin. So we've got our measurement of 3 feet. We're going to put our first pin at the 3-foot marker, and we're then going to draw a string to that point. And we want to make sure that we tie a tight knot there to keep that string tight. Then we're going to pull that string back to that corner pin. At this point, we're going to take our tape measure and go out 4 feet on the next leg. So our second pin we'll put at that 4-foot mark. And again, we'll draw our string from the corner to that pin. You then want to measure the distance between your 2 legs, so your second and your third pin that you put in. And that distance should equal 5 feet. If it's more or less, you might need to move one of those points to make sure that that hypotenuse is 5 feet. So here we have 3, 4, and 5. And therefore, we know that this is a square corner. And we'll go ahead and make our right triangle just like this. At this point, knowing that this is a right triangle, what we can do then is take our string and run it along those 2 pins, and you just want to touch them. And we can run this as long as we want, and we know that we're drawing a straight line and that we have a right corner. Now this is called the 3-4-5 method. You could actually double those numbers and make it the 6-8-10 method if you were building something larger and wanted to have better accuracy. Really, this is using the Pythagorean theorem. You might remember a squared plus b squared equals c squared. I think I might owe my math teacher an apology because I told her I'd never need to know this in real life.
Hey, I'm Eric Perkins, and on today's video, I'm going to show you one of the greatest carpentry tricks of all time. And that's using a 3-4-5 triangle to figure out if a corner is 90 degrees, okay? And what we're going to do, though, is double that. We're going to do a 6-8-10 triangle. We're going to figure out if this board right here is running off of our other band at 90 degrees, which is what we want, okay? So I have a fixed point out here. I can't move this in, so I can only move this in. What I've done is I've measured 6 feet from this surface out to a mark right here. What I've also done is measured out 8 feet in this direction. You can see this screw way out here, okay? Now I'm going to measure the hypotenuse, which is the longest leg of the triangle between these 2 points, and if it's exactly 10 feet, then our corner down here is 90 degrees, which is what we want. So let's check it. All right, 10 feet and 3/8. So we're a little off. What I'm going to do is make some adjustments, and then we'll check it again. The reason I'm close to start with is because I used my speed square in this corner right here to get it close. But this is a short length right here, so even if it looks close, when you go that far out, it could be way off. So that's why I'm checking this bigger triangle to make sure that this actually is 90 degrees coming in. All right, now I'm going to make my mark again 6 feet this way. All right, Now let's check our diagonal again, see if it's 10 feet now. All right, that's bang on it. So we have adjusted this piece to where we have a perfect 90-degree angle coming out of here, which is what we want because the decking will look good. So this trick can be used for all kind of stuff when you're building houses. You can extrapolate that 6, 8, 10 out. You can double it, triple it, quadruple it, and you can pull a huge triangle to get things square, including a whole foundation. We use this all the time when we're building. If you learn this trick, you'll be very glad you did. You'll be able to build things square, which is awesome. Thanks for watching. See ya. All right, I want to give a shout out right now to Mr. Cochran, who was my drafting teacher in high school, and also Mr. Livingston, who was my math teacher in middle school. That guy really made me pay attention, and I'm glad he did because now I'm still using math. Thanks, man. Kids, really pay attention to math class. It may be your paycheck one day.
Today we talked about squaring, what the word square means, you know, what it means in carpentry, the significance of it. We showed you some videos on different methods of squaring a project, but I wanted to show you the most accurate method of making sure something's square. Years ago, I've always been one to try to figure out the best way to do something. You know, back in the day, the way I was taught to square up something was measuring diagonally, you know, until you get the same measure. You might have to move back and forth and make adjustments, and that was a good way, but I got to thinking more about it, that, you know, this diagonal measurement thing, like it's got to be something to it. So I started thinking about it and trying to come up with a method of doing things a better way, more accurate. So I put 2 lines down and I tried to figure out how to get a perfect 90-degree angle. And I knew that diagonal measurement, it was the key. And if I knew this measurement and I knew this measurement, how could I figure out how to get this measurement? I got thinking about it, and I was thinking hard, and I come up with this formula, and it just worked perfectly.
Daddy,
What?
that's the Pythagorean Theorem.
Well, maybe I didn't come up with it, but it's a good one, and I like to use it. A guy named Pythagoras had a theory, and we call it the Pythagorean Theorem. In today's lesson, we've learned what the 3, 4, 5 method is and saw some ways we can use it. As your project gets bigger, you can multiply these numbers to make it bigger and make it more accurate. 3, 4, 5, you can multiply that by any number, like 2. So if you multiply it by 2, it would be 2 times 3, 2 times 4, and 2 times 5. So if you multiply it by 2, it would be 6, 8, 10. And the bigger your project gets, to make it more accurate, you just multiply it by a bigger number. So if you had, you know, a building that was 40 foot long, you could take that 3, 4, 5, multiply each number by 10, and you could have a right angle set up 30, 40, and 50. That would really help out, you know, if you want to get a bigger line for that right angle. It was mentioned earlier that this method comes from the Pythagorean Theorem. It's like a shortcut. But we're about to get into it now where we'll see why it's related to it. So we already know the answer to this problem. A equals 3, B equals 4, because we're familiar with the 3, 4, 5 method. But we want to learn why it works. A equals 3, B equals 4, C equals what? That's what we learned with the Pythagorean theorem, using A squared plus B squared equals C squared. That's the formula. If you remember that formula, and try to learn ways to relate and use this formula in real life situations, you'll find out you'll use it a lot more than you thought you would. All right, so let's work this problem out. 3a is 3, so a squared is 9. When you square a number, you multiply it by itself. All right, b is 4, so b squared is 16. We don't know what c is. We can use this formula and add 9 plus 16, and that's 25. So a squared is 9, b squared is 16, and c squared is 25. But 25 is not the answer. We want to know what c is, not c squared. So we get the square root of this 25, and c equals 5. Square root of 25 is 5. That's your answer. And that's how the 3, 4, 5 method works. It's a shortcut that we use because we already know the answer to it. We know we take a 3-foot leg, a 4-foot leg, and a 5-foot hypotenuse, that it'll make a perfect 90-degree angle. All right, what I want you to do now is pause and work this out. Get your calculator, work this out, and pause it. And when you get done, crank her back up. Let's go over what you got. All right, A equals 30. B is 40. Our answer we're looking for is C, the long leg of this triangle. All right, so A squared was what? 900. B squared was 1600. So we add these together. 900 plus 1600 equals 2500. All right, always remember, this is C squared. That's not your answer. The answer is C. So we know C squared is 2500. So what do we have to do? Get the square root. Get the square root of 2500. And the answer is C equals 50. So 30, 40, 50. All right, I want you to pause it again. Let's work this out using this formula. I'm just giving you the formula and see if you can work this out. Pause the video. Let's see if we got the right answer for this. If A is 36, and B is 48, we're trying to find out what C is. So A squared is 1296. Add that to B squared, which is 2304. Add those together, you get 3600. But that's not your answer. That's C squared. So you get the square root of 3600, and that's 60. So C equals 60. So you've learned how to use the Pythagorean Theorem to get that right angle. You got your hypotenuse, the long leg of the triangle, which is 60. Now we want to see how we would use it in relation to a real life situation. So the first thing you do, all right, and we know our building is 48 feet long. We know it's 36 feet high. And we know from here to that top point of 36 feet, it'll be 60. You stretch your tape measure out 36 feet, then you make an arc and mark on the ground or on a wood deck, or whether it's a concrete slab, you would make a mark in the shape of an arc. Then you go from the far end and stretch a tape measure out 60 feet and make another arc. Where these two arcs meet is a perfect 90-degree angle. You can also do it with tape measures, and instead of making a mark, just stretch two tapes out. Either you would have to anchor it here or get somebody to hold, but you can stretch the tape measure out 36 or past 36, stretch one out past 60, but where the 36 and the 60 feet mark come together, you put your pin there, and that will be a perfect 90-degree angle. Well, I hope you enjoyed the video today. Hope you learned something about squaring, how important it is, and ways to square. And when you have the opportunity to put it into practical use, you will see how simple yet effective these methods are. Next week, we'll talk about how to get the angles for different shapes. But before you go, I got a little questionnaire I'd like for you to fill out. It's on the next slide. See y'all later.